Welcome, comrades perennials, to another episode of the audio podcast, Synthetic. Artificial intelligence will not replace you, but someone using artificial intelligence definitely will. So sitting precisely at the absolute center of every single atom in your body is, well, a fundamental misconception, or at least the version you learned in high school chemistry is, essentially a work of fiction. I mean, it's a beautifully simple, easily digestible fiction, but a fiction nonetheless, because if you picture the device you are using to listen to this right now, or the chair you are sitting on, absolutely everything is built on an omnipresent anchor called the proton.
Right, and for a very long time, it was treated like this completely solved puzzle, just a quiet little cluster of static particles sitting at the heart of matter. But a publication from the journal Science, dated August 13th, 2026, by Wenliang Li, completely shatters that comfortable textbook definition. So the mission for us today is to entirely unlearn the classical model of the universe's most crucial building block by exploring a groundbreaking measurement just published by an international team of physicists known as the STAR collaboration. They have managed to solve a subatomic mystery that has perplexed the scientific community for decades. And to understand it, you really have to first, let go of a deeply ingrained image.
Yeah, because when you are initially taught about the proton, the classical view often presented is that it is a neat, easily defined cluster of three independent quarks, basically telling you to picture three simple, solid marbles sitting quietly inside a microscopic bag. And the logic of this classical view dictates that if you want to understand the bag, you simply add up the individual properties of marble 1, marble 2, and marble 3, and you predictably get the total property of the whole. But when we actually attempt to map the reality of the subatomic world, this classical reductionist logic completely falls apart. Instead of three quiet, isolated marbles, you have to envision an impossibly chaotic, localized storm, which is, a massive shift in conceptualizing reality.
Well, the modern view of the proton, which the Science publication by Wenliang Li meticulously details, defines it strictly as a many-body system. Because when modern instruments look deep inside a proton, they are absolutely not looking at the simple sum of independent quarks. You have to picture a violent, swirling hurricane of energy and particles flashing in and out of existence, forming a continuously dynamic space where the total output of the system is entirely different from just the isolated ingredients. You cannot understand the devastating power and behavior of a massive hurricane by just isolating a single drop of rain in a laboratory, and in exactly the same way, the proton is not a static object, but rather a constantly evolving energetic system.
Right. And the defining characteristics of a proton, the actual physical properties that dictate how it behaves in the universe, specifically its mass and its spin, do not belong to individual isolated quarks that you can just tally up on a ledger. Instead, these fundamental traits arise entirely from what physicists call collective dynamics. Inside that proton, the quarks are in a state of constant violent interaction with particles called gluons, which serve exactly the function their name implies. They are the fundamental constituents that physically bind the quarks together using one of the strongest forces in the universe. And the mass of the proton, alongside the spin that dictates its magnetic properties, are born directly from this unyielding binding energy.
So, the classical view fails because it tries to lazily map macro-world logic onto a profoundly quantum environment, meaning you cannot pull a proton apart, weigh its microscopic pieces on a tiny scale, and pretend you understand its nature. Most of a proton's mass actually comes from the sheer kinetic and potential energy of this internal storm, not the resting mass of the quarks themselves. You have to fundamentally think of the building blocks of matter not as solitary physical specks of dust, but as ongoing, highly active events. The scientific community has entirely moved past the idea of adding up static parts, and researchers are now entirely focused on observing properties that emerge exclusively from dynamic, continuous, and impossibly complex interactions.
Wait, hold on, because the scientific community has already rigorously figured out that this hyperactive soup of quarks and gluons actively creates the proton's mass and its spin. It seems highly logical to assume that the proton is a fully understood system. I mean, you just described a scenario where physicists have mapped out this chaotic storm of particles. They know the collective dynamics generate the measurable mass, and they know the interactions reliably generate the measurable spin. The complex mathematics of the quantum storm finally add up, and the structural integrity of the atom is maintained. Yet, the literature from the journal Science specifically describes the fundamental identity of the proton as something that has inexplicably remained elusive. This presents a massive logical gap, because if researchers possess the technological precision to map out how abstract concepts like mass and spin magically emerge from these incredibly complex internal quantum interactions, why is the proton's actual fundamental identity still heavily debated?
Well, the missing piece of this subatomic puzzle revolves entirely around a vital concept known as the baryon number, which the source text defines as a conserved quantity that fundamentally distinguishes matter from antimatter. To grasp why this specific detail is so critical, you have to fully consider what a conserved quantity actually represents in the realm of physics, which is essentially an absolute, rigid accounting rule of reality. It is a strict numerical value that must remain constant within an isolated system, regardless of what extreme internal changes, energetic fluctuations, or dynamic interactions occur within that system, acting almost like the ultimate cosmic ledger that the universe demands must always balance perfectly. The baryon number is the specific, non-negotiable accounting marker that dictates whether a particle exists as the solid matter that builds our reality, or the antimatter that would violently annihilate our reality upon contact. And protons have a baryon number of exactly 1.
So the core of the decades-old debate within particle physics is precisely about the mechanical reality of how this exact marker is managed inside the storm. While experiments have successfully and repeatedly shown that the proton's mass and spin are generated through the continuous collective dynamics of quarks and gluons, the actual physical mechanism for the baryon number has remained a total void in our scientific knowledge. The scientific community simply has not known how this fundamental identity marker, this crucial conserved quantity, is actually carried and transported within that incredibly complex many-body system. I mean, is the baryon number physically attached to the individual quarks themselves, or is it somehow distributed fluidly among the binding gluons?
Right. How does an ever-shifting, hyperactive storm of particles successfully maintain a perfectly rigid, mathematically conserved identity that universally distinguishes it from annihilating antimatter without a single error, ever? For decades, the mechanism of the specific transport within the proton has remained completely unknown, leaving the true physical origin of the proton's identity as one of the most frustrating, unsolved mysteries in modern subatomic physics. And visualizing the sheer mechanical difficulty of actually solving this mystery really highlights the almost incomprehensible nature of the experiment published on page 727 of this August 2026 issue by the STAR collaboration. You are essentially asking researchers to track an entirely invisible, strictly conserved mathematical accounting rule inside a chaotic subatomic hurricane that is, by definition, in a constant state of violent flux.
Yeah, how exactly do you isolate and track a rigid bookkeeping rule when the physical components supposedly carrying that rule are a continuous shifting blur of collective dynamics? Trying to trace the exact transport mechanism of the baryon number within a single proton is remarkably akin to trying to trace one single precise drop of specifically colored dye within a violently crashing massive ocean wave. And worse, to actually see where that drop of dye goes, you have to purposely collide that chaotic wave with another rogue wave just to map where the dye ends up splashing after the impact. You are clearly not dealing with a calm, static laboratory environment where you can quietly inspect the structural components under a traditional microscope, but rather intense, unbelievably high-energy physical states, where the very act of observation requires forcefully breaking the highly secure, complex system apart.
So the STAR collaboration somehow had to find a functional, experimental way to map the physical trajectory of a conceptual rule through the absolute most extreme physical environments imaginable to modern science. The monumental breakthrough achieved by them relies precisely on their ability to navigate, utilize, and measure the microscopic debris of those exact extreme environments. As detailed comprehensively in the science publication on page 727, the researchers utilized nuclear collisions to successfully execute the necessary experimental measurements capable of tracking the baryon number. When researchers deliberately smash heavy atomic nuclei together in massive particle accelerators at incomprehensible near-light speeds, they're essentially tearing open the highly secure many-body system of the proton.
Right, they are forcefully causing the complex internal dynamics of the constituent quarks and the binding gluons to spill out into a highly energetic observable state, basically creating a microscopic fireball that mimics the conditions of the early universe just microseconds after the Big Bang. So by meticulously observing the catastrophic aftermath of these extreme physical collisions, physicists are finally able to witness the actual physical transport of the baryon number in real time. The sheer violence of the collisions provides a unique mechanism to track exactly how this deeply conserved quantity moves, shifts, and distributes itself when the proton's collective dynamics are subjected to immense stress and ultimate separation. The researchers use massive house-sized detectors to track the exact trajectories, energies, and identities of thousands of subatomic particles that spray outward from the impact zone.
And by analyzing the angles and the specific types of matter and antimatter created in the debris, they can mathematically trace the flow of the baryon number backward to the exact moment of impact. It is strictly through the precise technological measurement of this microscopic shrapnel resulting from massive nuclear collisions that the star collaboration provides the long-sought resolution to the debate. The researchers are no longer simply theorizing about the mathematical existence of the baryon number in academic papers, but have successfully managed to experimentally track its physical movement. This provides direct observational data to finally answer the question of how this fundamental property of identity is dynamically carried within the proton's complex architecture.
You know, when you are confronted with this highly abstract, staggeringly complex scenario of deliberately smashing atomic nuclei together at near light speeds just to trace an invisible mathematical identity marker within a swirling quantum storm of microscopic debris, the immediate logical question you have to ask is about the direct connection between the micro and the macro. I mean, why should you, sitting here listening to a breakdown of particle accelerator collisions, truly care about the internal accounting mechanism of a baryon number? It is remarkably easy to view subatomic particle physics as an entirely esoteric pursuit, completely disconnected from daily human life, sounding like an academic debate over invisible nuclear collisions occurring deep in massive underground scientific facilities that have absolutely no bearing on reality. But we really have to bridge the gap between the complex experimental findings of the star collaboration, analyzing particle trajectories on page 727, and the massive overarching organization of the actual universe itself, asking why tracking a tiny accounting rule during a microscopic collision explains anything about the physical reality we inhabit.
Well, the ultimate implications of the star collaboration's experimental findings are profoundly significant precisely because the baryon number serves as the definitive boundary between physical existence and total annihilation. Because the baryon number is the absolute foundational property that distinguishes physical matter from its opposing antimatter, understanding its true origin is about vastly more than just cataloging the internal identity of a single microscopic proton. The publication synthesizes that this specific research provides direct foundational insights into exactly how matter itself is organized throughout the entirety of the cosmos. The physical reality you experience, the device you are looking at, the chair you were sitting on, the planetary body you inhabit, and the billions of stars illuminating the night sky is entirely 100% dependent on the strict dominance of matter over antimatter.
Yeah, every single atom in existence structurally relies on the proton's internal identity, remaining perfectly stable, conserved, and unchanging. Because if the internal mechanism carrying the baryon number were inherently unstable, or if the collective bustling dynamics of the quarks and binding gluons somehow failed to rigidly maintain this crucial conserved quantity, the fundamental structural foundation of all matter would instantly collapse into pure, radiating energy. Therefore, successfully tracking the transport of the baryon number through these extreme nuclear collisions is definitively not just an exercise in esoteric subatomic bookkeeping. It fundamentally and directly explains the stable structural foundation of absolutely everything that physically exists.
Right, and it reveals exactly how the incredibly complex, dynamic systems operating at the absolute smallest scales of reality successfully and continuously maintain the rigid physical rules necessary to build, anchor, and sustain the vast, stable architecture of the entire physical universe. It proves that the macroscopic stability we rely on every single second is actively generated by a chaotic microscopic storm that never rests. It completely redefines what we consider to be a solid foundation.
The next time you casually reach out and touch a solid object in your environment, whether it is a heavy wooden table, a smooth glass window, or even just resting your hand on your own arm, take a moment to deeply consider the entirely unseen, staggering reality of that physical interaction. You are directly interacting with countless trillions of protons whose very identities as stable physical matter, rather than violently annihilating antimatter, rely entirely on an ancient, unfathomably dynamic secret of collective interaction that humanity is only just today learning to successfully track. The seemingly quiet, static, solid world around you is actually built entirely upon a hyperactive, continuous subatomic storm, leaving you to quietly wonder what other seemingly solid, unquestionable aspects of your daily reality are directly beneath the surface, secretly functioning as massively complex, dynamic systems just waiting for the right collision to be fully unpacked. Subscribe to the podcast series Nuclear Locomotive, Neural Sawdust, and Synthetic. Namaste, thank you, and good luck.